Welcome to today's presentation, Cloud Native Applications with Habitat Builder. Let's go ahead and get started. Tasha, why don't you kick us off by telling our audience a bit about yourself and what we'll be covering here today?
Yeah, absolutely. Thank you, Jamie. So hi, everyone. I'm Tasha Drew. I'm going to be presenting Cloud Native Applications with Habitat Builder for you and showing you how to kick the tires with Habitat Builder with a demo. And just to briefly introduce myself, I am a senior product manager for Habitat, and I work at Chef. I'm currently focused with the Habitat team on building the next generation of cloud native application automation. Previous to this, I worked with several teams throughout Chef to launch and build Chef Automate's visibility platform. Prior to that, I have had various product leadership roles at Chef, Rentlytics, Engine Yard, and Lockheed Martin. I have a Bachelor's of Science in Computer Science from USC and a Master's of Science in Management from RPI. If you'd like to chat with me and follow up and ask questions or interact on GitHub, I'm available on Twitter, GitHub, and the Habitat Slack channel, which is public. Just so you know, as you get started with Habitat, we are super open to new people coming into the general channel on our Slack channel, asking questions and just looking for any assistance you might need. So feel free to jump in there. And if you want to ping me, I'm at Tasha in that channel. So what are we going to go over today? We're going to go over briefly technology evolution, the landscape today, and how Habitat plays into that. We're going to talk about the industry's shift to cloud native and how that impacts the people and processes in our DevOps organization. I'm going to go over what is Habitat, and then I'm going to show you a Habitat Builder demo. We'll also talk about some of the essential architectural underpinnings of Habitat. I'll point you to some additional resources where you can learn more, and then we'll open it up to Q&A. So enterprises struggle with delivering software. I'm sure that's not a surprise to anyone on the call. Some of us are better at it. Some of us have more challenges. But in the end, success with delivering applications and experiences are key to digital transformation. The problem that we see in a lot of the enterprises that we partner and work with is that many enterprises, to begin with, aren't very good at shipping software. And what that ends up meaning is that they have struggles in delivering new value to market in a timely manner so that they can really maximize their market opportunities. So results of this slow cycle means that there's slower time to market. They have poorer user experiences for their end users. Software is very expensive to ship and update. They're unable to predict when they're going to be able to launch a bunch of new features, and they're more exposed to vulnerability and risk because of the longer cycle that software shipping takes for them. At Chef, one of our key focuses is enabling and empowering our customers to move very quickly from having an idea and seeing immediate business value that could be maximized if that idea happened, and then giving you the tools that you need to ship that reliably and quickly. What we've seen in customers and enterprises that have really invested in and successfully implemented DevOps and the software tooling around DevOps is that 66% now see faster realization of business value. And Gartner predicts that through 2025, market demand for application development will outstrip supply by 5 times. So the market opportunity is huge, but we need to do some work to really be able to capitalize on it. Also, what we see in the market today is a shift to cloud native architectures. I'm sure most people on the call have read about 12-factor applications and what's really required to build a robust and scalable cloud-native application. But what we're seeing in the industry is that we have infrastructure-centric operations, which are served very well by the configuration management tool sets that are out there and that are fairly mature in their capabilities. So in that situation, when you're standing up a lot of servers and you want to programmatically make sure that they're all getting updated with their underlying operating systems maintained and updated, in that situation, situation, the unit of value is the server itself, the physical server or the virtual server, and the unit of work is configuring that server so that it can do the jobs you need it to do. So all of that can power your cloud implementations, your microservices, and your containers. But what we also see now is this gap and this need to have application-centric operations. And that's really where Habitat's vision and capabilities comes into play. With application-centric operations, what we have is that the unit of value is the application itself. All automation is done in service to the application, and then enabling that application to run reliably, predictably, and well, regardless of the underlying infrastructure. So here the unit of value is the application, and the unit of work is the deployment itself. And so what we're seeing is the two sets of technologies, how they work together and how their strengths can complement one another's. We also see shifting people and processes in order to be able to support this new application-focused software movement. So we have the modern application team, and they are very integrated. If you're on a modern application team, what you see is that your software engineers are responsible for building and running, and the overall lifecycle and maintenance and availability of the services that they're responsible for. There's less of a handoff between teams. They're at least collaborating very tightly with their operations team, and they most likely are doing some ops themselves. And as a result, these teams are highly empowered to choose the architecture and tooling that they need to use in order to get the jobs done that they're tasked with. What this is resulting in is the cross-functional team. Ops, the responsibility of ops, and the people who do the ops are moving up the stack, and developers, software developers, are moving down the stack and taking more responsibility for the purview directly beneath their application code, which they may not have done in the past. So this leads me into what is Habitat. Habitat is application automation that enables modern application teams to build, deploy, and manage any application in any environment, from traditional to cloud-native architectures. And I really want to highlight that Habitat is not a tool set that will only work for you if you have a net new greenfield designed from the bottom up cloud-native application. It will work great for you if that's what you have, and it will provide you a tremendous and powerful framework for you to build and eventually scale that net new application. But it also has the ability to work with legacy applications, and we've been very successful in helping our enterprise customers and partners transform legacy applications into a more cloud-native architecture by adopting the Habitat build toolset and pipeline. Habitat's design points. So Habitat is focused on allowing adopters to implement 12-factor application patterns without necessarily having to become distributed systems experts themselves. So what we're doing is we're decoupling the application from operating system dependencies. You can use your configuration management and the operating systems that have served you well up to this point, but the application now is more flexible and can run on whatever operating system you need it to. We're also decoupling build and run dependencies, and by having you explicitly declare those dependencies and then building an artifact that only has what your application requires to run successfully in production. As part of this, we're separating the concerns of build from deploy to provide improved DevOps collaboration. The modern application team needs to be empowered to choose the deployment tools that they want or need in order to accomplish the job that they need to do. Habitat does not seek to force you to use a certain deployment mechanism. Habitat seeks to complement all of your deployment mechanisms and then combine building and running your application so that whatever you're using to deploy and manage infrastructure, you have a robust, scalable solution to manage the complexity of your application and the services that it's dependent upon. We also provide declarative deployment capabilities as part of that. So this leads into DevOps for modern application teams. Modern application teams using Habitat have complete freedom of choice to use the programming language, services, and infrastructure that work best for their business needs and for the technology challenges they're facing. We're providing common processes across teams regardless of cloud, container platform, operating system, or VM platform. You can export a Habitat artifact into one of any number of different platforms simply by exporting it and then even by publishing it to a repository outside of Habitat, such as Amazon ECR or Docker Hub. So by doing this, what you're doing is delaying your infrastructure choices closer to the deployment through the correct separation of concerns. Today, you may have a hybrid environment where you need to run applications both on-prem, on VMs, on bare metal, in the cloud, on Amazon, on Azure, or on Google. Habitat doesn't care. Habitat says once you're building your application in this way, it is intensely portable to wherever you need to run it when you need to run it. So by adopting the Habitat build toolchain, you not only get a very programmatic way to achieve portability in cloud native application architecture, but you also are future-proofing your technology decision, because if you decide to change where you're deploying or how you're deploying in the future, Habitat will still support that new mechanism. In this way, we are providing you a common management paradigm regardless of architectural choices. So Habitat can be carved up into 3 phases or areas of interest. You build your application and you rebuild it as upstream dependencies and application code are updated. You deploy that into whatever cluster management or cloud or on-prem architecture that you need to use to get the job you're trying to do done. And then there's the lifecycle management of that application post-deploy. So for Habitat, the build phase is what Builder, which I'm going to demonstrate to you in a moment, really focuses on. And so here we are building your application. It's immutable, atomic, and isolated from the infrastructure beneath it, and this is the highly portable artifact that you can then take and run anywhere. As your application code is updated, we are then rebuilding your artifacts and porting them again to that format that you've asked us to post-build. This also means that you have a lot of the ability to very quickly respond to patch updates, security updates, and upstream changes to the underlying toolset that you're using, because you have this explicit declaration of the dependencies that your application requires to build and run, and Habitat's aware of those because you told us when you started building your artifact, when you started building your application. So as those upstream dependencies change, we can automatically or manually just kick off those builds and then provide those to your deployment mechanism to pick up and then basically deploy across your different environments according to your update strategy. So I'm now going to show you all a Habitat Builder demo. This is something that after this presentation, you can all absolutely go kick the tires with yourself. It's very simple. It should take about 10 minutes. It does use GitHub, and then it's also going to demonstrate how once you've built this artifact, you can connect and publish things to your Docker Hub registry. So I'm just going to get started. And please just note in the comments if this is in any way too small for you. I did move the resolution up, but you never know. So this is a demo. It's publicly accessible if you want to check it out. It's just at habitat.sh/demo. You can see that I'm already logged into Builder because I have my little icon over here. So how do I get started doing automated builds and then exporting and publishing Docker containers in a few minutes? What we've done is we've provided a simple node application. And so you can simply go to GitHub and grab this node application, and then you're just going to fork that to your own repository. I have already done that, so I don't need to, but if I click the button, you can see I've already done it. It's pretty simple. So once I have forked this repo into my GitHub, it's right here. So you can see that it's just a simple Node app. We're going to see it here. And we have some instructions if you want to follow them down there, or you can just follow the web UI. But basically what I'm going to do is I'm going to go to the Habitat folder, and you can see that I've written a plan. A plan is how we in Habitat describe to Habitat how you should be building me. So I'm going to say what my package name is here. I share my package origin, which is Tashimi. I have my package scaffolding. Scaffolding is a higher level concept in Habitat, which means that we have built the automation for several different application languages so that you don't have to customize anything in Habitat beyond simply saying, I am a vanilla application of this type, and I declare that type. So here I'm saying I'm a pretty normal Node app. Please just fill out all of my automation using the scaffolding. And so we're doing that, we're declaring our scaffolding, and then Habitat basically does the rest for us after that. So if you're just getting started, you will need to follow this step, which is sign into Habitat and then go and authorize Habitat Builder to connect to your GitHub repo. What connecting Habitat to your GitHub repo does pragmatically is allow you to sync your application code and your Habitat automation instructions with Builder. And then every time you push an update to your master branch, Builder will grab that new code and kick off an artifact rebuild for you automatically. So this is just a certain level of automation that's available to you to grab and then use going forward. So now that I have signed into Habitat, which I can do by clicking on the Builder button, I can go to My Origins. So here are My Origins. I have a couple different ones, and this is the Tasha origin. So I'm doing a brand new origin just to kind of quickly demonstrate to you all what this would look like when you sign in. Private builds are off for this origin. Habitat Builder provides the ability for you to have both public builds if you're building an open source project or something that you want to share with the world, and also private builds if you have things that you want only restricted to you or people on your team. And then team management is very simple with the members selection over here. So I need to add some origin keys. I can just generate a key pair for myself by clicking a button. I now have these, and then I'm going to go back, and I'm skipping this part because I already had an origin ready to go. And then I'm going to go and edit my sample plan, which I haven't connected to my origin yet, but this is just because this is now going to be in the Tasha origin. And so this is a brand new version. So this is a new package in the Tasha origin. I'm going to call it 1.0. And then I'm going to go down here. And I'm going to save this to GitHub. So, and then I'm going to commit my change. I'm going to commit it directly, which we don't normally. So I'm skipping a review process, but just for the sake of a demo. And now we have it. So here's my new plan. I've updated it for my new origin. And now I'm going to go over here and I'm going to connect this plan file. Cool. So as I connect the plan file, you're going to install Habitat Builder, which were these steps right here. And then you can install it on your personal GitHub account or an organization that you're an owner in. This is simply giving us those requirements. And then we need to add our Docker Hub. So for Docker Hub, what we're going to do, this may not work because of a naming issue, so I'm going to switch to Tashimi where I've already set it up. So I've already connected the plan file in the Tashimi origin, so you can just see that here's the sample node app. It's all set up. Integrations. So I click on integrations, and I can add any of the supported container registries. We're always interested in knowing if there's more places that you would like Habitat to have an integration for. Just let us know in the comments, reach out in the Habitat Slack. For now, what we have is Docker Hub. So I can build my application and port it over to Docker. And then we have Amazon Elastic Container Registry. So for this one, I'm going to connect a Docker Hub account. I've actually already done that, so you can see that here. It's very simple. I simply enter my integration name, which can be whatever you want, and then I log into Docker Hub right here. So once I've done that, I have now connected my package. So we can see here, my package is connected, and now I have a button that says build my latest version. So all I have to do to kick off an initial build is just click that button, and then that'll kick off a build. And so looking at build jobs, I can see a new build is in progress, and I can see all of the streaming logs if I'm curious about just what's happening over here. So kind of looking through this, okay, we're building a bunch of stuff, that's awesome. And then what's going to happen is Habitat is taking my application code from that repo. It does have an update because I changed this right here. And then it's going to build the new application artifact, save it here to Habitat's, to my Habitat origin, then export it into a Docker container from its Habitat artifact, and publish it to Docker Hub using the integration I've set up. So pretty simple. Just for some cooking show magic, to kind of skip this, we can look at one that I did yesterday. And so this is a build that took about 2 minutes. I kicked it off yesterday evening, and it just has all of the information for what we did to build this application. It's pulling down all of my build time dependencies to build it, and then it'll pull down all of the runtime dependencies for Node application. And then it's going to create this immutable, isolated and atomic artifact that we can then export into a Docker container. And so here we can actually see where that's happening. So now I had a local Docker image, and then with tags that I had requested be associated with that, and that gets then published for me to Docker Hub. So on the command line, we can basically pull down our application as a Docker container. So this, call it the right thing, sample node app. Oh. Maybe. Oh, it's probably because the rebuild's in process. Okay, we will give this a moment and wait for the rebuild to occur for us. And that should be totally fine. But basically all you need to do is go, once the rebuild's finished, pull your Docker image, run it on your machine, and then you're going to see that we are running both your Habitat node application locally, and then you can just go to your local host, 800, and see it running there for you. So just to quickly show you some of the features that I kind of glossed over as I was showing how the build jobs work. What you can do when you click on My Origins is see the Tashimi origin, see the packages that are associated with that, and then see the information from this manifest. So this is giving me a lot of information about the checksum, which is a built-in feature of Habitat so that I can verify that the image that's running is the image I built. And then I have some tags here so I can see that this is an unstable build. I can see what version this is. So I had said that my earlier version was 1.0.2 because I made 2 updates. This is the release number that gets automatically generated when I rebuild it. I can see system architecture information for the image that I created. Habitat has, you can do Linux and Windows builds with Habitat. So that's part of the reason that we're so explicit right here. And then you can just find an upstream URL. So you can basically tell people where to find the upstream project's website or homepage, which is required if you're doing an open source project that you want to share with people so that they can see it. You can declare a license and a bunch of other information. So as a developer, when I'm looking at open source packages here that I can inherit and use to build my projects, perhaps I want to use the core team origins Postgres or Redis or various pieces, I can go and investigate those core packages just by looking at this information and really understanding what's going on here. So these are you are creating an immutable artifact that's configurable with the basically configuration settings that you've set up when you start your automation. So here you can see I have made ports configurable, and this means that I can call that port later after I deploy this if I need to change it and configure that around my Habitat application without needing to do a rebuild to change something fairly simple to tweak. Here I can see what my dependencies of my application are. I'm depending on the node package and the BusyBox package. And I can also see the transitive dependencies, which are dependencies that BusyBox and Node can rely upon. So we're going all the way down to glibc here, you can see. And what this does for me is this means that when I have a transitive dependency that has an upstream change, I am going to rebuild that first and then rebuild the packages that depend on it afterwards in what we call a reverse dependency build, so that I always have the latest version of every single dependency and transitive dependency in my ultimate artifact for me to call upon. And that's how we can be very confident that applications built with Habitat are going to only have one version of every underlying dependency running on every single node. And you can query all of those nodes via their supervisors, ask them what version of software they're running. And if you have a vulnerability that you're concerned about and you want to query your fleet, you will know that there's no transitive dependency underlying the main dependencies that hasn't been updated, because they can only be linked to one version. So going back to build jobs, oh no, the problems with live demos. Okay, so what we can do here is simply re-kick off a build and see how that goes. I'm not sure why that one failed, but I can go in here and look at the logs. It may be because I changed my origin name to try and use the Tasha one. Yeah, that's exactly why. So I screwed this up, basically. And what I would need to do to fix it is go in here and rename this one Tashimi and put 3 here. And now my keys can match. And then I'll have to kind of wait for this one, because now I'm going to append another build that failed. So I'm going to go back over here and instead show you so breaking down what I just showed you. Here are the pieces of Habitat that we just really focused on, which is the build piece. So building is about better application packaging. What we're getting with Habitat is a consistent process for packaging all applications across all architectures. The scaffoldings that I showed you very briefly are a simple way for key languages. So we have those for Node, Ruby, Go, Java right now. And then but Habitat can also work with any application language as long as you are but you will have to do some more configuration yourself. So with the languages that we support for scaffolding, it's very easy to get started as long as you're doing a fairly vanilla application. If you're using Ruby, for example, and the Ruby scaffolding, we can just go and scan your makefile and see what your dependencies are for you and then fill that all out. If you're going to do a C++ or a Rust application or Python, then it takes a little more setup time. So the goal is to get every major language to have a scaffolding, but for now we just have them for a handful of languages as we get going. And the build piece works with your current source controls and CI/CD workflows. If you are using GitHub, if you're using GitHub on-prem, if you're using Jenkins. Habitat doesn't seek to say, hey, you need to migrate away from this. What it seeks to do is make you more powerful where you are. You don't have to adopt the entire workflow of Habitat to get a lot of benefit out of the pieces of Habitat. So just have that as a note. For deploy, Habitat can target any format and runtime. And what's important is that there we go. And what's important is that you don't have to do any configuration work to get the application that you have written to work on those formats and runtimes. So what that means is the build artifact is separate from the deployment artifact. You build your artifact and then you export it into the format you want to deploy, and that gives you flexibility and deferred decision making. All knowledge of the application dependencies are included in the deployment artifact. So you're not going to have a problem with a handoff between dev and ops, because the artifact itself has the information it needs to run once you've deployed it. This assists lift and shift or lift and modernize strategies in mixed portfolios, as well as simply providing you a robust tool chain that can evolve as your own strategies evolve for where you want your application to run. For the management piece of Habitat, Habitat is focused on automation for applications. This means that we're giving you consistent management capabilities in any runtime environment. So you can tell your Habitat applications what their clustering topology is, you can auto-configure them after you deploy them as you need to tweak values. You can also tell them what their update strategy is. Should they be doing rolling updates? Should they just never update, because that's a very sensitive manual process you have to control? Are they extremely ephemeral and can just update all at once? That can all get baked into the automation of the application itself. So this is allowing you to build specifically for distributed stateful application topologies. And it is work that you're going to have to build in a custom manner at some point as your application scales. But the idea with Habitat is that we're giving you a generic format and interface so that you don't have to recreate the wheel as your application matures. So just to kind of quickly go over some of these concepts, when we're packaging applications, a user writes a plan. The plan is used to build your application artifact, and then that application artifact lives in the builder depot. Then when you take that to run it, you take the artifact out of the depot and export it into the format that you need for the job that you're trying to do. And that can be a bare metal format, containers, AMI, VMs, just whatever's right for the job. The Habitat build philosophy. So historically, what we've seen in the evolution of operating systems is that a lot of people have tried to create a golden image that they can just run across a really huge fleet of servers that is able to do a bunch of different jobs without a lot of tweaking. And what that means is that it's a great operating system, but it is definitely too bulky for a lot of the jobs that it's doing, because it's trying to be capable of doing every job instead of a single job. And what we see with the way that container formats are being adopted right now is that those formats are recreating that traditional model where we have this bloated one-size-fits-all operating system and libraries, and then kind of smushing our application and application-specific libraries on top of it. So that's why we have this pyramid on the left. What that's bad about is abstracting the build and run aspects of applications. So we end up with bloated containers that have a lot more underlying dependencies than the application itself actually needs, because we're trying to have a one-size-fits-all. With Habitat is building from the application down. So the operating system has been built entirely in service of what the application's dependencies are, because you told us what it is. It's only been built with the underlying packages that the application requires to run. It has this embedded supervisor for application lifecycle management, and builds have strict dependency version control down to all the way through the entire application and operating system. So the goal of Habitat and sort of the vision of Habitat is to have happy devs, happy ops with Habitat. Developers get GitHub integration, automatic rebuilds as they commit to their repo, explicit dependency declarations, and stable and unstable release channels. For operations, you get an immutable build artifact, automated container builds, application exports to Docker, Rocket, Mesos, Cloud Foundry, Kubernetes, and tar, and release channels for a CD workflow. I'm going to take a quick pause to ask you all to submit your questions. We're super excited to answer anything. I know this has been a ton of content, and this is really focused on the build part of the life cycle, potentially just because there's a lot to cover with any kind of segment of Habitat. So we'd love to answer your questions, and we'll try to get to as many of them as possible. And then just to point you at more information that we would love for you to check out, our website has a lot of information on it. It's habitat.sh. If you would like to try the demo yourself, and I promise you will have a lot more success than I did just because I was switching between origins, you can go to /demo there or click the try button. We have several really helpful learning tracks on Chef Rally that take you through how to build your Habitat application. All of our code is open source and on GitHub if you'd like to come to our GitHub repo. And then we do have that Habitat community Slack channel at slack.habitat.sh. And there, the entire engineering team and I are happy to help and answer any questions that don't get answered in the Q&A portion of this talk. Cool.
Excellent. Thank you so much, Tasha. We do have a few questions that have come in, so we'll go ahead and get started. Folks, feel free to continue to keep adding those in, and we'll get to as many as we can in the time we have left. So the first question we have in, can you talk a little more about how you use Habitat and Kubernetes together?
Yeah, absolutely. So the way that, Habitat has a bunch of ways that you can use Habitat and Kubernetes together. One of those is the Habitat operator for Kubernetes, which we've built in conjunction with our partners at Kinvoke. And what that is an operator is a Kubernetes concept that allows you to use the Kubernetes communication mechanisms via etcd and the API controller model to have Kubernetes native communication with the Kubernetes cluster. So basically what you're doing is you can come to Habitat and start building your application with Habitat, and then simply say export to a Docker image, or we're going to be launching a bunch of stuff for KubeCon next week, so export specifically to Kubernetes. And then your Kubernetes cluster can grab your application and then deploy it across your Kubernetes cluster. You can also continue to use kubectl, and because you're using the Habitat Kubernetes operator, your Habitat application and your Kubernetes cluster will stay in sync. So we have a fairly robust set of initial offerings to enable people who are using Kubernetes to quickly build both their ephemeral applications that live really well on Habitat, and then their more stateful services, like perhaps a really beefy database that belongs more in bare metal or VMs, and you can build that workload on Habitat too. Export your ephemeral application to Kubernetes and run that in a Kubernetes native model using a Habitat Kubernetes operator, and then put your more stateful services on VMs or bare metal if you prefer, connect the two using the Open Service Broker API, and then you just have one tool chain for all of the jobs that you're trying to do.
Awesome. Thanks, Tasha. Will Habitat highlight vulnerabilities in transitive dependencies?
So Habitat will grab the latest version. So I don't know if you've noticed, but GitHub launched a little while ago the ability to send you an alert when they know that you're relying on an underlying dependency that has a vulnerability. Habitat if Habitat is subscribed to that GitHub repo, it will simply grab that update and then rebuild your application for you using that updated software. And then what we need to add to kind of tell you that we do that is basically say, so we're going to be adding notifications to the application. And so we will have rebuilt your application for you because your underlying transitive dependency got updated. But then, so you will have a new application. And then what we need to do to provide a really robust user experience is also simply send you a notification saying, we rebuilt your application and this is why, so that you know that there's a higher level of sort of impetus for you to get that out to your production environment.
Right on. Okay. How does Habitat change the local developer workflow? One of our attendees is getting pushback from devs who prefer Docker Compose and throwing it over the fence to ops.
Yeah, absolutely. So with Habitat, instead of writing a Docker Compose file, you can write a plan file. And the idea, what we have right now is in the local development experience, if you download our CLI and use the Habitat Studio instead of using the UI-focused experience that I just showed you, is you have this local experience within your terminal where you are booting up a studio, writing your plan, pulling in packages, testing your application, and then you can either have that immutable artifact that you then share, or you can share that up to Habitat Builder to have a central location where you're sharing it from. So as far as like, how do I port a Docker Compose file into Habitat, we don't really have that story nailed down, but what we do have is simply, instead of Docker Compose, you can write a plan and then you can still get that Docker container. But what it's giving you is it's giving you a much stronger chain of control over how these artifacts are getting built. So what we've seen a lot of customers do when the developers really don't want to get started with Habitat is that the operations team will simply write a plan for them, and then the developers don't really have to worry about it. But in the future, what we're looking to do is really improve our local developer experience by creating so right now we have this Habitat Studio that's very focused on the build experience. What we want to do is build a Habitat Studio that's very focused on the developer experience. So you would simply open this studio locally in the directory that you have your source code, and then it would start to provide you a very quick and easy and integrated way for you to start saying, okay, I've made some changes and now I want to have an artifact and a local Docker container so that I can locally view my changes and decide if I want to commit this build back up to Builder and share it with my team. And so the idea of sort of having that really compelling local development experience from a developer's perspective as well as from an operations perspective is something that we're evolving to, and that's in our relatively short-term roadmap.
Great. Okay. Yeah, good information. How does the workflow change if my org is already heavily invested in AWS Code Build or Code Deploy or another tool and don't want to leverage the Builder service?
So I guess that kind of I guess what I would wonder is like kind of what are you using, what ends up being the artifact that you're deploying, and are you does this question kind of mean like I just want to use like the runtime capabilities of the supervisor instead of Builder, or is it kind of asking how do I integrate Builder with Code Deploy? So I guess I would need more information to know how to answer that.
Fair enough. The person that asked that question, if you want to throw in some more information, we'll try and get to that or follow up with you via email to address that. Okay, moving on. Could you compare Habitat and its legacy alternative or describe the differences? What does Habitat improve from its predecessor, whatever that predecessor might be? I'm more of an infrastructure guy, and Chef's technologies are rather new to me.
Yeah, absolutely. So Habitat doesn't have a legacy alternative other than sort of patch a bunch of different tools together and kind of glue them together yourself, or build your own pipeline. And that's why I think Habitat has a really strong market opportunity. So right now, what we see people doing is, especially if they need to start having like a container build pipeline, for example, is adopting a technology or building their own technology that simply takes their application workloads and then starts to containerize them using various container build pipelines. What Habitatsh is doing instead is saying, there is a really smart programmatic way for us to break down the build problem and the build questions of how I build and deliver my applications that doesn't have to be restricted to containers. And perhaps even the container build solutions that exist today are not as robust as really allowing you to drill in and define what are my build time dependencies, what are my runtime dependencies, how does this application behave once I deploy it into various environments? And let's just programatize all of those, make it incredibly declarative, expose some tunables that I'm going to need once I deploy this, and then start rebuilding every time an underlying dependency, transitive dependency, or source code is updated. That hasn't been built before. People have built solutions that do it. If you talk, and then the runtime capabilities of Habitatsh as well, there are other technologies that do part or some of what the supervisor and the ring will do for you for the application lifecycle management piece. But the idea of having the build piece of Habitatsh and the runtime piece of Habitatsh fully integrated to allow you to be doing all the rebuilds, have your supervisors out there running your application, have them be aware of an update, be able to self-organize and sensibly install that update, and then with very minimal human intervention and having that all automated and included in the artifact that we originally ship. That's a pretty new idea, and the end-to-end experience hasn't been replicated by any existing technology.
Perfect. Thanks, Tasha. So how does Habitatsh integrate with CI and CD?
So Habitatsh, so it kind of depends. So if you're using a CI/CD solution that you really like, Habitatsh can complement it. What Habitatsh itself offers is as you build your application artifact, that application artifact is posted to what we call a channel. So we have 2 default channels in Builder, and then you can add as many channels as you want depending on what your environments look like. So for the purposes of conversation, let's say that I have a development environment, I have a QA environment, and I have a production environment. And then I say, I want my development environment to get every update as it comes out, which may not be realistic. So I'm rebuilding my application artifacts. My application artifacts post to the Habitatsh unstable channel. I create a development channel and I say, just put everything, just promote every artifact that hits unstable directly to development. Then in my development environment, my supervisors are running applications and they are aware that they have an update strategy. And that update strategy can be never, if you want this to be manual. It can be rolling, it can be one at a time, it can be all at once. So I see that I have an update that's been posted from development to my development channel. I'm a supervisor in my development environment, and I am subscribed to that channel, and I have a rolling update strategy. And I am the what we call the update leader of my service group. Okay, I grab that, I download it, I tell everyone in my service group that we have an update so that they're also doing the same thing, and I'm coordinating with my peers to install this update. Within the supervisor, I have application lifecycle hooks, which allow me to automate the behavior of this application when different lifecycle events are happening. So I can run smoke tests, I can run compliance tests, I can do whatever I need to do to make sure that I'm very comfortable with this update happening. I run through all of those, I decide the update's good, we as a group coordinate to install this update, and we then say, okay, we're successful, and then we keep running. As a developer or admin, I can now see that my development environment has a new update and then promote that update to the next environment, which in this case would be QA. The same pattern would be followed by those supervisors, which would be subscribed to the QA channel. And then once I'm satisfied with that, or even have multiple updates come into QA because I only want to do a release every so often or at a certain time, I can then promote the QA channel artifacts to my production channel. And then my production supervisors will behave the way that I've asked them to behave as far as grabbing that update, running it through their checks, and installing and running it. And then obviously,
okay, right on.
Yeah, cool.
Tasha, why would I use Habitat and Cloud Foundry together?
Yeah, that's a great question. So Habitat and Cloud Foundry are complementary technologies. Right now, Habitat, when you have built a Habitat artifact, you can export it as a Cloud Foundry Docker container. We've also had several large Cloud Foundry customers adopt Habitat in order to expand the capabilities of their Cloud Foundry managed platforms. So one of those that I would love for anyone interested in Cloud Foundry and Habitat to check out is GE Digital, and they have done a couple videos, including a really great talk at ChefConf that are on the Chef YouTube channel, if you'd like to watch that. But basically what they were doing is they were extending their stateful services using Habitat to build, deploy, update, and run stateful services, including elk stacks, so like Elasticsearch, Logstash, Kibana, and a bunch of other services that they were then providing as services to users of their Cloud Foundry platform as a service.
All right, thank you. I think we're going to take one more question before we wrap up here. What if I can't rebuild my software?
Oh yeah, so if you can't rebuild your software, if you're using packaged or licensed software, you're going to void your support warranty or whatever it is, you can simply have the Habitat supervisor supervise that package itself instead of having Builder rebuild it for you. So we have had people who needed to do that. You can still, if you want to expose some tunables, so you're still getting the benefit of being able to configure and create this package and have it communicate back. But then you can consume your updates via your regular software vendor instead of directly via Builder, and then have the supervisor manage the lifecycle pieces instead.
Excellent. All right, well, thank you so much, Tasha. Since we're almost out of time, are there any closing remarks you'd like to make before I close us out? Thanks, Tasha. Since we're almost out of time, any closing remarks before I close us out?
Yeah, I'd just like to super encourage everybody to check out our website and hit us up in Slack if you have any questions. We are super available to answer those and help you get started. I hope that you give it a shot and let us know what you think.
Excellent. We'd like to thank our audience for your live participation today. For those of you that submitted questions that we didn't have time to answer, we'll follow up with you via email and address those in the next week or so on the Chef blog, where we'll recap everything we covered here today. As a reminder, a copy of today's slide deck and additional help materials are available in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and then bookmark any links that you may find useful. We, of course, hope you found value in the information that Tasha presented today. If you like what you saw, we encourage you to share the recorded presentation with your teammates and professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. Thanks again for your time, and have a wonderful day.